This is Geometry, Unit 7, Day 15. We're working on the Law of Cosines worksheet. When we look at this triangle, we're trying to find the value of segment AB. That's across from angle C, so we could also call it side C. Notice that we're starting out with side angle side. We don't have two bits of information, so law of sines would not work here. We would need to use law of cosines. So we like to start out with the formula. So write out your formula with each of the letters and then plug in the values that we have. A is 29, so 29 squared. B is across from angle B, so that's going to be 13 squared, minus 2 times 29 times 13, cosine of our angle. So our angle in this case, of course, is 41. So we could solve that out by doing each operation individually. But if we're going to use a calculator anyway, let's type this in. We'll say 29 squared plus 13 squared minus 2 times 29 times 13 cosine of 41. So we get the answer of 440.95. So notice that on the calculator, that answer actually went on more and more. So when we take this calculation of trying to figure out what C is from C squared, we have to take the square root. And because we don't want to write down every value that's on your calculator, we just round it to the nearest hundredth. But when you do the calculation in your calculator, be sure to take the square root of the answer. And the answer button is found typically towards the bottom. A graphing calculator also has it at the bottom. You just have to hit shift first with the negative button. So that's going to give you 20.99. If you round that up, that's going to come out to be exactly 21. So here, just to be sure, we're going to say that that's 20.99, but that's being rounded up to become 21. I don't want to imply that 21 squared makes that value. Okay, now we're looking for BC. BC is across from angle A. So we don't have two bits of information, so we cannot use law of sines for this. So we need to use cosines. So A squared equals B squared plus C squared minus 2BC cosine of A. Side C is across from angle C. Side B is across from angle B. So A squared equals 21 squared plus 30 squared minus 2 times 21 times 30 cosine of your 123. So we'll go down to our calculator. By using the calculator, this will save a lot of errors. So we typed in 21 squared plus 30 squared minus 2 times 21 times 30 times our cosine of 123. So we got 2027.25. So when we look and we notice that in our calculator it goes on and on, and even more numbers come after here. So we round it because we can't write every number exactly. When we calculate this, we're not going to type in 0.25. We might write it, and that value is going to come out to be approximately the square root, and we're going to use the answer button, so that brings up the exact value, and that comes out to be 45.02. Here we're trying to find segment AB. Segment AB is across from angle C. Notice we don't have two bits of information. We don't have angle B and side B. I have side A, but I don't have angle A. I have angle C, but I don't have side C. So law of sines would not work here. So we're going to use law of cosines. C squared. We know that A is across from angle A. Side B is across from angle B. So A squared is 22, or A is 22, and we're going to square that. B is 20, we're going to square that. 2 times 22 times 20. Cosine of 95. So we'll bring in our calculator and type in 22 squared plus 20 squared minus 2 times 22 times 20. Cosine of 95. So that's going to come out to be 890.97. Well, I take that back. When you type that in, you're actually going to come up with 960.697. So we can write that as 960.70. And then we'll take the square root of both sides of our equation. And we know that we're going to use the square root button with answer. So we're going to bring up the answer so we get a very accurate result. 30.99. And if you look, you'll see that it's 30.99 with a 5. So you could say that it's about 31. That's implying that it's not exactly 31, but it is about 31. Now we're going to look at the angle A. Notice what's different about this problem. For one, of course, we're finding an angle. And two, they originally give us all three sides. So we're, of course, not looking for a side. We have all the sides. So we're going to start out with A squared, B squared plus C squared minus 2BC cosine A. Now, to get the cosine A by itself, we're going to subtract across the B squared, subtract across the C squared, divide by the negative B 2BC. That's going to give us the cosine of A. So now A, of course, is across from angle A, B is across from angle B, and C is across from angle C. So 10 squared minus 17 squared minus 11 squared all over negative 2 times 17 times 11. That should give us the value of cosine of A. Be sure to write your formula and be sure to take time to plug in the values. Don't just use a calculator. So now, to type a fraction into a calculator, we need to use a numerator. So to be sure that we get the numerator, all these values in the numerator, I'm going to use parentheses. Then we can type in 10 squared minus 17 squared minus 11 squared. All of that's in the numerator, the top of the fraction. So then we put a parenthesis around it to close it off. Then we're going to divide that by this denominator. So we have to start parentheses again for the denominator. So you want to find your negative key, not the minus key, but a negative key. It makes a difference in a calculator. 2 times 17 times 11. And then close off your denominator. Very important to use parentheses correctly so you can get the result of 0.82. This is 887, so we're going to call it 0.8289. Now we're looking for an angle. Cosine of A is not the actual degree value. To calculate the degree value, we need to move the cosine away from here. So we're going to call it cosine inverse of 0.8289. That is the measurement of angle A. So again, we come to our calculator. We want to use the real value, not this rounded number, but the real value. So we're going to say cosine inverse of the answer. You want to be sure to use the answer. You need to learn to use that. So we got our answer of 34.02 degrees. That's the measurement of angle A. On the back side, we're going to work with triangle XYZ. Notice that X is an obtuse angle, and we only are given information about one of the angles, but it's obtuse. So when you draw your triangle, you want to do your best at being sure to represent it so the sides are proportional as much as possible to the numbers that we're given. We have X at 138. Now you can name the other vertices in any order that you want. I typically go alphabetical: X, Y, and Z. Side Y is 15. Well, side Y is going to be across from angle Y. So we use a small letter Y, and that equals 15. Z, we'd use a small case Z, and that's going to be 25. So notice again here that this triangle, we have side, angle, side. That's one of the situations where we use law of cosines. We don't have 2 bits of information to use law of sines. So what's going to be a bit tricky here is that we need to come up with the formula, not with A, B's, and C's, but now with X, Y's, and Z's. But we've talked about how to write the formula. So we're going to start with x squared because that's the side that we're looking for. The other two sides are called y squared and z squared. Then we say minus 2 times those two values times the cosine of the angle that you're looking for. So we can plug in numbers now. We don't know what side x is. We know that y is 15, so 15 squared, 25 squared, minus 2 times 15 times 25, times the cosine of our angle, which is 138. We'll go to our calculator, and we'll type in the numbers 15 squared plus 25 squared minus 2 times 15 times 25 times the cosine of 138. That comes out to 1,407.36. So now we know what x squared is. To figure out what just x, the segment x is, or the side named x, we take the square root to get rid of the square. Now, if in your calculator you type in that exact number, you'll get an answer pretty close to what we have. But if you type in what we had before, using the answer value, that's going to help out the best. So by hitting the square root key and the answer, that's going to bring up our real value into the square root. It's the radicand, and that whole value that goes on and on will be part of the calculation. So your best answer is going to be 37.51. You can use approximate symbols if you wish. And our units for this happen to be inches. 25 inches, 15 inches, so x is going to be inches also. Now we're working with a triangle. We notice that the letters here are Q, R, and P. Q is a lowercase q, and it's 12. P is across from angle P. And then R is across from angle R. Here we're given all three sides. We need to find the measure of angle P. So if we're going to look for angle P, we're going to start our equation with P squared equals R squared plus Q squared minus 2 times RQ cosine of angle P. Well, if we're solving for angle P, then we're going to subtract R squared across, subtract Q squared across, and divide by negative 2 RQ to get the cosine of angle P. So now we'll plug our numbers in. P is 28 squared, and minus 18 squared, minus 12 squared, over negative 2 times 18 times 12. That should still be our cosine of P. So that's our cosine of P. We use our calculator to type this in. So 28 squared, well, this is a fraction, remember, so we need to use parentheses to represent the numerator. 28 squared minus 18 squared minus 12 squared, close off your parentheses. So that's the entire numerator. You're welcome to hit enter if you wish, but we'll keep that whole numerator together. divided by, here's our denominator, -2 times 18 times 12. It's very important that you use the negative key, not the minus key. And you have to use parentheses or the answers won't come out right. So in this case, we're getting -0.731. Let's round that up to a 5. That's for the cosine of p. So for us to calculate this, remember, we want to move the cosine away. So we're going to say cosine inverse of -0.7315, and that's going to equal the measurement of angle P. For us to figure out what that answer is, we're going to say cosine inverse of our previous answer. You want to use the answer key. Don't type in rounded answers. So we get 137.01 degrees. Our last question. Here we're at Canton High School, then Imagine Theater, and Target, and they form a triangle on a map. So we're out here at Imagine, Target, right down the road on Ford Road. Over at Canton High School. Now the way that I've drawn this, it doesn't quite look like it, but the angle at the school is supposed to be 86. So this is 86 degrees apparently. The distance between the movies and the school is 8 miles. And the distance between Target and the school is 6 miles. Find the distance between the movie and Target. So that's our unknown. So, if you wanted to put this together, calling it A, B, and C, you could definitely do that. This could be your E, this could be T, and maybe this was C. So we're really looking for side C. So we're going to have C squared that equals E squared plus T squared minus 2 times ET cosine of C. So we're looking for the length for C. Side E is across from that angle, which is 6. Side T is across from target, which is 8. Then we type in, or we're into our equation, we're putting the 6 and the 8, cosine of our angle, which is 86. So, using our calculator, 6 squared plus 8 squared minus 2 times 6 times 8 times the cosine of 86. And we get the value of 93.30. And we'll take the square root. We'll write down this 93.30, but when we do the actual calculation, we're going to hit square root of our answer. That gives us 9.66.